Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 14, using half-angle identities, Part 4. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Full disclosure, this used to be part of Video 13, but Video 13 was too long, so it got cut in half, and here's Video 14. In the previous video, we used half-angle identities to simplify expressions. Just a reminder, when choosing the plus minus in an identity, it's based on the trig function of the half-angle and the quadrant of the half-angle. In this video, we use half-angle identities to verify new identities. For example, verify the identity. 2 cosine squared of x over 2 times tangent of x equals tangent of x plus sine of x. In typical fashion, we'll start with the left side of the identity. And notice that we have a cosine squared of x over 2, or rather the square of cosine of x over 2, which means we can use its half-angle identity. Keeping the square but replacing the cosine of x over 2, we get 2 times the square of plus minus square root of 1 plus cosine x over 2 times tangent of x. Clearly, the square is going to cancel the square root, but it's also going to cancel the plus minus, because regardless of whether this was positive or negative, when it gets squared, it becomes positive. Hence, we're left with just the 1 plus cosine x over 2 inside the parentheses. I think the next two moves are fairly transparent. The 2's are going to cancel. That leaves the 1 plus x inside the 1 plus cosine x inside the parentheses. And because our final destination, tangent x plus sine x, does not have parentheses, we need to eliminate our parentheses and we'll distribute. That will give us tangent plus tangent of x plus cosine of x times tangent of x. Now let's analyze where we are versus where we want to go. We want tangent of x plus sine of x. We have tangent of x plus cosine x tangent of x. So we want the tangent of x that's up front, the first tangent of x, but we don't want the second tangent. So we need to get rid of this tangent, and what better way to do that than to replace it using a quotient identity? Tangent of x equals sine of x over cosine of x. And I think you see the end now. At this point, we'll cancel the cosines, and we'll be left with tangent of x plus sine of x, which was our final destination. If you were to clean it up and write the flow more fluidly with the justifications, it would look like this. I'm not going to read it all to you because it's exactly what we just did, just line by line, step by step, justification by justification. Remember, if you're not doing a trig move, you're doing algebra. Let's try one more. Verify the identity. The square of sine of x over 2 plus cosine of x over 2 equals 1 plus sine x. Again, we're going to start with the left side. However, because of the structure of the left side of the equation, we have a couple of options on how to start. We can either do trigonometry by using half-angle identities twice, or we can do algebra by squaring the binomial. Both are okay, but the identities would insert square roots into the expression. Would you rather have an expression with square roots or without? I think without. I'd like to avoid the square roots if possible. As such, I will choose the algebra move first and square the binomial. At some point, it will have to be squared anyway, so let's do it now before the insides of the parentheses get messier. If we were to write the expression twice and multiply it out, we would get sine squared of x over 2 plus 2 sine of x over 2 cosine of x over 2 plus cosine squared of x over 2. That's a basic algebra move. Notice we can capitalize on a Pythagorean identity. After we multiplied it out, we have sine squared of x over 2, and then over here, plus cosine of x squared over 2. And according to a Pythagorean identity, that's equal to 1. So our expression collapses from what you see on the bottom line to 1 plus 2 times sine of x over 2 cosine of x over 2. Now we have the 1 plus part of our goal. But compare what we want, which is sine, to what we have, which is 2 sine x over 2 cosine x over 2. Something's got to give. Now use the half-angle identities. Well, you could, but What we have down here suggests a sine double angle identity. Sine of 2x equals 2 sine x cosine x. So we're going to use that double angle identity to condense this down to sine of twice the angle. The angle being x over 2, however, when it gets doubled, cancels, and we're just left with 1 plus sine of x, which was our goal. So even though this identity involved half angles, notice at no point did we use a half angle identity. We did algebra at the front and capitalized on the double angle formula structure of the remaining half angle expressions. Sneaky, sneaky. Now, could we have used square roots and used the identities? Of course we could have. Here's the fluid flow with what we did. And had you chosen to use the half angle identities first before we foiled, here's how it would look. Now, you can pause the video and look at it line by line. I don't have the justifications, but they would be half angle identities, algebra, 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 algebra. There's a Pythagorean identity towards the end. One thing I couldn't justify, though, is that because the identity uses plus minus, some of the plus minuses vanishes when they square, but in the middle, I couldn't justify that it would come out positive, so I can't justify why this must be positive. I'm interested as to why, but I'm not going to waste any more of your time. My advice is your first move is critical. That's the takeaway from this identity. Now you try. Pause the video and try the following. Okay, that was supposed to be a pair of identities. What happened? Okay, you know what? I'm not going to do take whatever of this video. I think this is like take 7. You can try to simplify the expression if you want, but really focus on verifying the identity. 1 minus tangent squared of theta over 2 equals 2 cosine theta over 1 plus cosine theta. Pause the video, give it a try. Give them both a try if you like, but this is the same problem from the end of the previous video. All right, if you haven't paused the video, here's your warning. Solutions in 3, 2, and 1. Again, this first one was just left over from the previous video. I'm not going to do a take 8. But to verify this identity, if you looked at 1 minus tangent squared and started thinking Pythagorean, that would not really get us anywhere, because if you look at the Pythagorean identity involving tangent, it's 1 plus tangent squared equals secant squared. The one and the tangent will have the same sign as long as they're on the same side of the equal sign. So I can't manipulate that identity to make it say 1 minus tangent squared. However, I can replace tangent squared of theta over 2 with one of the tangent identities, tangent half angle identities. I chose the square root one because it's about to get squared. It would kill the square root and the plus minus, leaving 1 minus cosine theta over 1 plus cosine theta. And in anticipation of subtracting fractions, I rewrote the 1 as 1 plus cosine theta over 1 plus cosine theta. And upon subtracting carefully, watch your signs when you subtract the second fraction, it should collapse down to the desired result.